In this tutorial, we will be going over Ansible, its features, core concepts, and some example Ansible code. We will then use the code we reviewed to deploy a Minecraft server to the Vultr instance we deployed using Terraform in the last tutorial. First, we will do a brief overview of Ansible. Ansible is an automation tool used to make repetitive tasks less tedious. Tasks are defined in an easy-to-read YAML format. In the first section of this video, we will go a little more in depth about some of the features of Ansible. Then, we will touch on some of the foundational concepts. Ansible uses concepts such as playbooks, templates, tasks, handlers, and vars to create the code used to deploy applications. Next, we will look at some Ansible code. We will go over the directory structure I use for my Ansible projects and dig into the YAML files to see exactly what instructions we'll be providing Ansible with to deploy our Minecraft server. Lastly, we'll be doing a deployment of the Minecraft server using the Ansible playbook. And then we'll jump into Minecraft and take the server for a spin. Everyone loves Minecraft. What's not to love about breaking blocks, building with blocks, and crafting new items? Ansible is an open source automation tool that boasts the ability to run anywhere. Its primary method of interacting with machines is through SSH using Python modules. Ansible has an agentless infrastructure. There's no need to install anything else on your machine to get Ansible to run. It's predictable. Ansible code is always executed in the same way. Running a playbook one time or multiple times should render the same results. Ansible is flexible. It has support for a plethora of network devices, operating systems, and APIs. It can be used just about anywhere. And it's also extensible. If support doesn't currently exist, you can write your own collection or module to add support for whatever you need. There are a few concepts that you will need to understand before working with Ansible. I will briefly discuss some of the key concepts, but not all concepts will be relevant to the content of this tutorial. The control node is where you will run your Ansible command line tools to execute your deployment scripts. In this video, the control node will be my local desktop. In Ansible, the managed nodes are the hosts your Ansible code will be running against. Sometimes you'll hear these referred to as target devices. Your managed nodes are defined in your inventory file. Your inventory file is a list of managed nodes. In the inventory file, you will specify things like host groups and IP addresses. Another common name for the inventory file is a host file. Playbooks are how we describe to Ansible what we want it to do. Inside a playbook, we define plays, which are used to correlate tasks to managed nodes. Roles are a distribution of Ansible code that can be reused inside of a play. Tasks are actions that are meant to be applied to a target device. And handlers are a special kind of task that is only executed when notified by another task. Modules are code that Ansible will execute on a managed node. Each module is used to perform a specific task, such as writing files, installing packages, or configuring firewalls. Plugins are code that is used to expand on the base capabilities of Ansible. Plugins can control many things, such as how Ansible connects to managed nodes, or how Ansible interacts with certain types of data. Collections are a way of storing and distributing code, such as playbooks, roles, modules, and plugins, through Ansible's repository called Ansible Galaxy. Collections are a great way to reuse resources that other people have already created. Now that we've briefly touched on the core concepts behind Ansible, let's look at the code we'll be using to deploy our Minecraft server. In this section of the video, we will be looking at an example of an inventory file, a playbook, a task file, and a handler file. I like to structure my Ansible directories with handlers, tasks, templates, and vars, all inside of their own directories, an inventory and main.yaml file in the main directory. The inventory file contains the definition for the Minecraft group with the host called MC. There is also a variable for SSH common args set to ignore strict host key checking. This just makes it easier to connect to a newly deployed server. This server is the one that we deployed yesterday using the Terraform code. If I only have one playbook file, I will typically name it main.yaml. In this file, you can see where we're telling this play to run against all hosts, telling it to run as root. That's what become true means. Telling it our variable file is located in vars/main.yaml, and defining the tasks and handlers that will run as part of this play. Once again, with my tasks file, if I only have one, I will typically put it in the tasks directory and name it main.yaml. The repository with this code is available on GitHub. In the tasks file, we have used modules to instruct Ansible to install OpenJDK, unblock the port required for Minecraft, create the Minecraft group and user, and download the Minecraft jar file, create the EULA and server properties files. Then, towards the end of the file, we also create a systemd service file and start the Minecraft service. In the tasks file, when we created the templates, there was a notify restart Minecraft. That is calling a handler from handlers/main.yaml. There can be multiple handlers in this file, but in this case, we only needed one. Now that we've gone over the code, let's run it. To run the playbook using the Ansible CLI on my control node, I will type Ansible playbook -i and specify the path to the inventory file, which is just inventory, then the path to the playbook, which is just main.yaml, and finish off the command by telling it to run as the root user using -u space root. While this is running, you can see it's starting off the play install Minecraft, gathering facts about the server, and then it's included the task from main.yaml, so now it's going through and it's going to install OpenJDK, and it will just go from top to bottom all the way through the task file that we provided it with. This run will probably take about a minute to go through, but we can just see here everything is, as it's getting done, it says changed. If it's something that doesn't need to change, it will just say OK, or if it failed, it will say failed. All right, and it's done running. So now that the playbook's finished running, we can see there is a Minecraft server running at the IP address and port shown on the screen. I just used the debug module to output that message at the end of the run. Once we've loaded up Minecraft, we can go to multiplayer, and then click on add servers. I'll just put a server name in here as MC. It can be whatever you want. Then I'll paste in the server address that I copied from the end of the playbook run and click on done. Here we can see the Minecraft server that was just created, and join server. And we're in the game. Can break blocks, place blocks, and it's working. Thanks for taking the time to go through this tutorial with me. Hopefully you learned something from it, and you can use Ansible and Terraform in the future for some of your own projects.